Hello class, in this lesson we're going to be exploring the idea of a problem that we need to solve. Give me just a moment. Okay, I'm going to tell you about a question that I want to answer, a very important question in mathematics. And this is a question that arises when we do bivariate analysis, which is what this chapter is about, right? Bivariate analysis. Oops. So let me tell you about the question, guys. First, we're going to be addressing this question and the way of solving it in either 2 or 3 steps. And these are quite long, so just take your time, relax, understand each of the steps so that we can give a proper conclusion and answer to this question. Okay, so let's start. Let's imagine this, guys. Let's imagine that we make a hypothetical thought experiment in statistics. Okay. I mean, this is hypothetical, but it actually could be done in real life. We're not gonna do it, but we could do it. So let's see. What is this experiment in statistics about? And by the way, forgive me for the poor handwriting. So it's about this. Imagine that in a single shift, see that we have 600 students, which is roughly the amount of students that we have in a single shift. So that's my population, right? This is the population on a single shift. Okay, from this population, I'm gonna take a sample of just, let's say, 15 students. And as we know, this is known as a sample from my population. And I wanna perform bivariate analysis on these 15 students. 15 students. What variables am I gonna observe from these 15 students? I could be observing a lot of stuff, right? Their ages, their weights, their scores in the final exams, many things. I'm going to choose the following two. My two variables will be their height and also their weight. Okay, so from each of these 15 students, I'm going to be observing their height, their weight, and I'm going to record that on a proper chart. Okay, so here I have the chart. Suppose you have the chart here, it's height and weight, right? And here I'm going to be putting all the observations. And that is the experiment. This is classified as an experiment in statistics, right? Okay, now imagine the following, guys. Imagine that after I do this and after I come up with my chart full of 15 observations, remember that each observation is a couple of numbers, one for the height, one for the weight. And then what I do is the following. I'm gonna draw the scatter diagram for this particular chart, right? So in here I'm gonna put the height, in here I'm gonna put the weight. Remember that it is essential that we also put the units in which I'm gonna measure height and weight respectively. Let's measure height in meters. Let's measure weight in kilograms. And let's suppose that we come up with something like this, guys. Imagine that these 15 students, when I plot them on a scatter diagram, the information looks like this, more or less. One student, two students, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. Okay, imagine that this is the scatter diagram for this chart. First, let's analyze this data point here. What do we call this data point? We call this an outlier. Outlier. Why? Because it clearly falls outside the general trend for the other points, right? This observation in here presents uh, a strange behavior, so to speak. Okay, it's just not normal. It falls outside what we consider normal. I mean, in this case, it's gonna be very hard to think of a person whose height is 1.8 meters and whose weight is 40 kilograms, right? So either we made a mistake in the observation, which is perfectly possible, or probably this person, if we want to explain this outlier, perhaps we can say that the person is ill, or perhaps some other explanation, right? And we can actually, you know, when we have an outlier like this, we can, in some instances, ignore this outlier so that this doesn't skew my analysis that much. So in this case, I guess it's wise to take it out the set of observations. Okay, so next, look at this set of points, guys. And by the way, let's erase this, right? Let's erase this guy. Okay, let's just focus on this other. What can we observe between the height and the weight, between these two variables? If I ask myself, is there any correlation between them, between height and weight? Well, it's quite clear, at least visually, that yes, there is correlation. How can we describe it? We can describe it as positive, linear, because they seem to be following a linear trend, right? And in regard to the strength of the correlation, it seems to be from moderate to strong. Okay, so yeah, there's correlation. Now, here is the question, guys. The question that I want you to understand in this video. And by the way, in this video, which counts as the step number one in our analysis, in this video, I just want you to understand the question. That's it. That's all I want you to do. We're not gonna do any math, nothing. This is purely conceptual. So, what is the question? The question is this, guys. This was my sample, 15 students. For these 15 students, I actually know each of their heights and each of their weights. So for example, if I pick the person that whose height is, let's say, 1.73 meters, okay, I can know perfectly well what was his height. I'm sorry, his weight, right? Because I measured such weight. You see? But the interesting question is this. The interesting question is, what if we chose one of the students that wasn't picked up in this sample? Okay, one of the people, I mean, there are 15 students in this sample, right? What if we choose another student among these ones, but that is not included in the sample? And what if we know the height of this person? What if we know the height? The question is, as you may be guessing, can we predict the weight of this person by knowing the height? That is the question. Can we predict the weight of this person right here, by knowing the height? Okay, so this is a question of prediction. The answer, what is the answer, guys? The answer is yes, we can. Yes, we can, to some degree, obviously. Our prediction will not be perfect in any way. To some degree, we can actually predict such weight, not perfectly, okay, with some degree of error, but I mean, at least we can get a prediction. And how do we do this? This is the important question. right? And in here, I just want to explain to you briefly, conceptually speaking, broadly speaking, how we can address this question. If you look at the scatter diagram between the height and the weight, we already agreed that the trend is linear, right? And perhaps we can do the following, guys. Perhaps I can create a linear model. Maybe this was not the best color. A linear model of the trend that these points are following. What does this mean? A linear model. What it means is this, guys. Imagine if we could fit a straight line going across these points, kind of like this, kind of like this. Okay, more or less. So when you think of this line, guys, you can more or less observe that this line more or less represents the behavior of this set of points, of this set of observations. They seem to follow more or less this line, not perfectly, but more or less, right? And if I drew another line, perhaps I can draw also this other possibility. Okay, this is the blue line, this is the yellow line. We can clearly see that this is not a good line to represent the behavior of this set of observations. You see, this is a good line, at least conceptually speaking, or broadly speaking, visually speaking, and the yellow one is not. The question is this: how can I decide which of these two lines, which of these lines is the best? The best in what way, or in what context, or by what quantitative parameter? By by best, I mean the one that best represents the behavior of these points. And we need to make that extremely precise. What do we mean by the line that best represents the behavior of these points? Let me tell you what that means. First, let me erase this one, which is clearly not the one we're going to be looking for. It's more or less this one. What do we mean by the best line in this context? It's the following, guys, and this is the crucial part of this explanation. You may need to replay this part maybe 2 or 3 times, as many times as you want, in order to understand what I'm talking about. So let's for a moment assume that this blue line is the best one, the best that represents the behavior of these points. What does that mean mathematically speaking? It means the following. Consider this point, for example, this observation. This observation represents a student whose height is this one, right? And whose real weight is this one. This is the height of this person. This is the weight of this person. These are the real values that I observed during my uh, data recollecting. Okay, now what you should notice is that this line, guys, can be used for predicting the weight of this person if I only had the height. Okay, this line predicts a weight of, let me go with yellow once again. Okay, if I only had the height of this person, if I only had the height, then if I wanted to use this line in order to predict the weight of this person, what I would have to do is go continuing with this line until I reach the line, this blue line, and then observe the predicted weight that this line would offer for this particular person. So this point here, guys, that's the predicted weight. This point here, that's the real weight of this person. You see? And basically, we can understand this little bit, this little section, or this little segment, this, which is also the same as this, right? If we do a translation, this is the error. That is the error in the prediction. error in the prediction of the blue line, of the line. You see? Now, for example, for this particular point, for this particular individual, right? This is the error. You see? It is basically the distance from the point to the line in this particular way, in a vertical way. Because we can also speak of the distance from this point to this line in this way, like perpendicularly, but that's not the one we're addressing. We're addressing this one because this represents the error between the real weight of this person, which is this one. This is the real weight, and the predicted weight given by the blue line is this one. You see, this is the real, this is the predicted for this particular guy right here, according to its height, which is this one. You see, guys? So basically, if I did the same for each point, let me try to clean up this a little bit. Let me just hang on. Okay. So if you can imagine, guys, the set of all the points that I had before, I erased, I think it was over here. This doesn't really matter. Okay. Now imagine all the errors between these points and the line. I'm gonna put that in red. So this is the error for this line, for this point. This is the error for this point. Error, 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 and so on for each of them. Can you see? There's a very small error for this point. There's a very small error for this point. For this point, there's a lot of error, and so on. So take a look at these segments of lines, guys. Okay. And here comes the important aspect. Here comes the good part. What do I mean by the best line? The best line, or the line that best represents the behavior of all of these points, is the following. Here is the crucial aspect. The best line is the one that minimizes the sum of the errors, okay, which are all of these, right? It's this plus this plus this plus this plus this plus this, all of these little segments, guys. If I can find somehow a line that minimizes those errors, that's what I understand by the best line, okay, that represents the behavior of these points. And that's why you can clearly see now in retrospect that a line such as this one, let me exaggerate my point. A line such as this one, this would be an awful representation of the behavior of all of these set of points. Why? Because now let me do that in blue. Because the error between this line and these points is way too much. Like, look, this is the error from this point to this line. This is the error, error, error. Can you see? We have huge errors if I decided on this line as the best line representing the behavior of these points. So clearly the blue line, which is this one, is much better at minimizing this sum of errors than the yellow one. You see, and that is conceptually speaking, guys, conceptually speaking, at least what we mean by the best line representing a set of points. And that line in particular has a specific name, and it goes by the name, hear me out, we call this line, the blue one, we call it the line of best fit. The line of best fit. That's what I want to keep. That's what I want to give you at the very end. This name, la línea del mejor ajuste, which is the one that I already explained to you. That's the one that minimizes the sum of errors between the prediction and the real values of the weights. In this particular example, right? I mean, for other experiments, these two variables are going to be different, but for this particular one, The line of best fit is the line that predicts with less error the weights of these people if I know their heights only. That's it. I'm gonna stop right there. I just want you to understand conceptually what the question is. This is the question: can we predict the weight of a person outside the sample by knowing the height? And the answer is yes, we can to some degree. And how do we answer that question? By modeling or by finding the line of best fit. Once I have the line of best fit that describes my sample, then I can use it to investigate another individual that was not inside the sample. You see? That's how it works, conceptually speaking. Now, the rest of the steps number 2 and 3, they're gonna be devoted to actually, number crunching and doing the real meat and bones of the analysis, right? This is just conceptual. So that's it, guys. I'm gonna leave you right there. If you have any question about this, you can ask me either today or the next lesson at the very beginning, because I'm gonna pick it up from here and we're gonna start analyzing how we can find this particular and very special line in statistics, the line of best fit. Okay, thank you guys.